Hello and a warm welcome to today's XM webinar about continuous testing of HiL test cases. Before I start, just a quick introduction from my side. So my name is Moosburger. I'm a project manager at MicroNova, and I'm responsible mainly for the development and additional services of the distribution of the XM test automation solution. Also project manager for some additional plugins and features that are improving the possibilities of XM. And before we start, I'm going to give you a quick introduction about the topics of today: continuous testing of XM, integrating XM into a continuous testing workflow, also giving you a bit background information about what XM is, basic introduction as always in our webinars, what is continuous testing, what is our interpretation of having products around XM that helps you to integrate XM in a CI workflow. An example how we could integrate XM to interact with a build management system like Jenkins. And as another interpretation of continuous testing, also to show you how scheduling of test works with the help of the test cloud controller. Next to the theory report, of course, we also have some live demonstration about our products and solutions that we're going to explain you. And right at the end of the session, we are also open for your questions. So XM itself is a test automation solution that was developed as a freeware solution by the VW group. And it's an enterprise solution that comes with a 3-tier architecture, mostly for the validation of ECUs. But due to its open interface policy, it's also possible to think of other validation scenarios. The creation of the test is based on a model, and surely it also contains components for your automated test execution and also to check the results in an evaluation component of XM. So since it is freeware, where can you get XM? You can download XM, the client and the server components, along with tutorials and additional supplementary documentation on our website. And we also provide a core library that contains basic interfaces and some example codes to run those core library functionalities. The tool itself also contains some tutorials and an integrated online help system. And you can also find the recordings of our sessions on our website here. So you should be fully equipped with additional information around XM. So to start with, a little bit of an explanation, what about the main perspective of XM? So the tool itself, it consists of 3 main perspectives. I explained before, to design your test cases, you might want to start with the modeler perspective. It helps you to design and implement your test cases, to parameterize them, to do a modularization, to increase the reuse of your test case, and also to compile your tests to get them prepared for the test execution. There are also features to display and to design and edit your object relationships between the objects you stored in the model-based approach of XM. The test runner perspective is the next step here in the test automation tool. You can launch your test suites and your test campaigns inside the test runner perspective, and surely you can, during the active test runs, monitor your current test results. It also allows you to filter the scope of your test cases and to save and store the compilations of your test suites or test campaigns. And last but not least, the major perspective is also the report manager, where you can check on the results of your automated test runs, compare them, check on the valuations, and find out why some test cases might have been error prone. It also has a feature to generate nicely formatted reports with the help of the BIR template. And in terms of a result management, you can also update your test results if you think about the post-valuation of the results. So a little bit of process overview here and about the roles that are involved here inside the XM test automation process. So the workflow starts on the left side with a test specification engineer who can provide a test specification and the requirements the prerequisites for the test designer to implement the test case itself in the XM model perspective. That's the model-based approach, and the specification acts as the template for the test designer. Storing the test case in the model also triggers an automated code generator here running on the server component and prepares the runnable Python code as the runtime environment here for the test runner to launch and start your test cases. So somebody like the tester, he is in charge of taking control of the test runner and getting the tests prepared in an automated way. After the execution, somebody like the test reviewer can use the XM report manager to do the report generation or to also check on the results of your test runs. Yeah, as you can see below, we have additional information about this webinar and also about XM. If you just scan the QR codes, then you can get a lot more information about this. So what is continuous testing? Before I start, a little bit of a definition. Continuous testing itself, it's a subordinated form or a process step underneath the continuous integration methodology. That's a methodology of having a continuous software delivery pipeline. And the idea here and the motivation for us to come up with some projects that enhance XM is to transfer XM into some kind of continuous integration environment. I think it's, let's say, common knowledge here to mention the benefits and to be aware about the benefits of a continuous integration process. It helps you at first to get quick and continuous feedback about your code changes. You can also pace up the speed of your development because you are able to easily and early integrate your new code parts. And also getting and obtaining feedback pretty early in your development stages also helps you to increase the software quality. And surely there is an increase of your automation level. So you can reach out to a high degree of automation. As you can see on the right side here, the different steps of a testing evolution, starting on the left side with the manual tests. This shows us the lowest level of test automation. And surely by introducing a test automation tool like XM, you can reach out to a higher test automation level. And our idea today, and also to introduce you to two of our products, how to reach the next level of test automation by thinking about tools that can, in some terms also automate the test automation tool of XM itself. So in terms of a continuous testing process or an additional workflow step of continuous testing in your CI workflow, the tools XM Jenkins plugin and Test Cloud controllers come into play. Now let's start at first with the Jenkins plugin. So how did we match or did we succeed here with integrating XM into Jenkins and the interaction with a build management system like Jenkins? So let's have a look on this continuous testing workflow here. That's just one possible illustration here about CI workflows. Let's just keep it plain and simple. Most of them also contain aspects like the feature and the release management. We just want to show the close alliance between development and the testing process here. So starting on the left side, you can see the development, like a development team that is managed by a certain amount of people. And you have a tool like Jenkins that is taking care of bringing all the different code parts together and taking care about the build jobs to generate your product or your software application. And the idea is now that next to your Jenkins build jobs to build your development or your software application, the additional workflow step is to introduce now continuous testing into your CI tool. So having an integration of continuous testing means that Jenkins is capable to install and get the XM environment prepared. So jobs will be triggered here and the XM clients are then linked again, as you are well familiar with, to your HiL systems. So that the tests are still started on your XM test runner component and then the clients are connecting to your HiL system. And at the end, the results from your test automation, they can easily be converted and brought back to your Jenkins environment. So you have the Jenkins test results and the development team can get the feedback from your automated test results. Surely you can also check in the XM report manager about the results, but it helps you to quickly get this feedback and quickly get information about your integration steps and integration cycles of your development. Let's have a closer look on this Jenkins job workflow. So let's just start here at the bottom, where you can create a job. It's one of the standard features of Jenkins and having a Jenkins master that you can create a job. In this case, the job is not to build and manage the build of your actual software application, but to add an additional build step here by means of the XM Jenkins plugin. So next to the XM Jenkins job, the XM Jenkins plugin as an additional open source component for your Jenkins environment helps you to set up and to configure the different testing slaves that are connected to your Jenkins master. So normally in a Jenkins environment, you have the testing slaves, and the specific part is here that the XM Jenkins plugin is able to install and to configure and to get your test runs prepared. So for all of these slaves, you can see here inside the slaves that we have an additional component, the XM REST API plugin, which helps to communicate between Jenkins plugin and the XM client itself. So your project, your P-code synchronization, and also the pre-configuration of your test suites or test campaigns is controlled and supervised by the XM Jenkins plugin. Also getting back the results and so on is a communication between the Jenkins plugin and the REST API plugin. And next to the execution here, it's also one of the features of Jenkins that you can trigger or define trigger events, how this job can be started. So this can happen in a nightly build run, so on a scheduled daily base, or when you do the code commits into your or for your software project, or somebody can just manually invoke the job execution. So let's just summarize up again the main features about the XM Jenkins plugin. So at first, you have an automated setup of the XM environment because of the interaction between XM Jenkins plugin and the REST API plugin. So you can also install XM client itself on your test slaves, and additionally also the Python environment that is required for your test execution. The preparation and configuration of XM test runs also includes, next to the definition of your test suite, which filters have to be applied to your test runs. So you can narrow the scope of the executed tests, thinking about multiple iterations of your tests, like smoke tests, system tests, or specific function tests you want to execute. And you can transfer all the XM test results to a JUnit XML format. This JUnit format surely can be parsed by a build management tool like Jenkins. Some additional feature is also the invocation of Groovy scripts, or you could also trigger model import and exports by means of the XM Jenkins plugin. And you can also think of an easy integration of XM to other CI systems, like Bamboo from Atlassian. The XM REST API plugin is the other player to which the XM Jenkins plugin is communicating to. So the XM client has an add-on that comes up with a RESTful web service. And the web service is the base for the communication between the Jenkins plugin and the XM client installed on the testing slaves. So at the end, I'm going to show you also the Jenkins test results, how this looks like. So if you're familiar with the dashboard of Jenkins, then you can see here on the left illustration, on the left screenshot here, how the test results would look like. This is like a representation of a test suite and exam. And you can also navigate inside the test cases up to down to a level of subtests, and also check on the different valuations here of the subtests. You can also check the valuations about your subtests and also see which tests are error prone, and do a deep dive into the error prone tests and find out why the tests have failed or something like this. But you're getting all this feedback back to your central Jenkins instance. On the right side, this is also quite nice to illustrate here a trend chart of Jenkins when you have multiple pipeline jobs. So here you see like the history of the different jobs here, all for the same test suite. And you can also see how your test suite or the execution result of your test suite improves or gets even worse with this trend chart. But enough now from my side, from the theory part. We have prepared some little live demonstration here of a pipeline job with XM. My colleague Rudy is going to give you this brief introduction into the Jenkins plugin, and also to show you how we realize this continuous testing solution here.
Hello, my name is Rudi Loderer, and I'm a software developer at MicroNova. I hope you can hear me. And as soon as you can hear me, so I think everything is fine. And before showing you the web UI of the Jenkins plugin, I want to show you a typical exam test suite. To keep things simple, I want to use this predefined exam test suite, which is included in the examples package of each exam client. In order to run this test suite locally, you can double click it, and then exam switches to the test runner perspective. In this perspective, you can use this green play button in order to run the test suite. After selecting the system configuration, you can press finish, and the test suite starts to execute. Once the execution of the test suite has finished, you can view the report which was generated in the exam report manager perspective. Here we can see that the test suite contains 4 test cases. 3 of them evaluated to info and 1 to failed. So the next question is, how do I use Jenkins in order to run this test suite continuously, maybe nightly or on each push to a Git repository or something like this? To manage all these configurations, you can use standard Jenkins mechanisms. So I will show you how to configure a job with the help of this predefined job. And I will switch to the configuration perspective of the job. And in here, you can see the standard configuration page. On top of the page, there are some general configurations like the description, some plugin configuration, and the build triggers. And at the bottom of the page, you can see the pipeline script. This pipeline script is very simple, and I will give you a quick introduction into the most important parts of the script. So the script consists of 3 parts. The first part configures or specifies the agents which are able to run this job. The second part are some general options, like if the logs should contain timestamps and how many builds should be kept. And the third part of the pipeline definition contains the definition of the procedure of the job. So in this case, the job consists of 4 steps. The first step is to clean the cache of exam. The second step is used to run a specific exam element, in our case, the Hello World test suite. The third step collects the test results and uploads them to Jenkins. And the fourth step uploads the generated PDF file. So this description is not really intuitive. So I prefer to use the exam pipeline syntax editor to create them. And I will show you how to use it, or how to use the pipeline editor. Simply click this link. And then you can use this generator to configure the steps. So within this drop-down menu, you can find 4 steps which are delivered with our Jenkins plugin. The first step is used to clean the cache. The second step can be used to run Groovy scripts. The third and the fourth step are very similar. They are both able to run specific exam elements. I will focus on the fourth step. This step is called exam test model. And once you select it, you get this really easy to use interface. In this interface, you can specify which exam version should be used to run the job. Then you can select the model, which contains the exam element to be executed. Then you have to configure the Python version. And now the interesting part begins. Here, you can select the exam element to be executed. In our case, we want to execute the test suite. So this input field does not contain such a fancy drop-down menu like the field above. Instead, you have to insert the UUID of the test suite. In order to get the UUID, you can navigate to exam and open the modeler perspective. If you select the test suite and navigate to the properties tab, you can find the UUID at the bottom of this tab. Simply copy it and paste it into this input field. Repeat the same procedure for the model configuration and the system configuration. Once you have configured all these general settings, you can continue to refine your settings or your configuration. So you can add some filters, which means you can filter the test suite which will be executed. So you might want to run only tests which have an attribute named engine. And the value of the attribute should contain this regex to the load letters or something like this. And then only the test cases with an attribute engine whose value contains this regex will be executed. If you don't want to filter the test suite, you can simply uncheck this box. In addition to the filters, you can also configure the logging, and you can configure the report target. So you can configure that the report of the test suite should be uploaded to the report to be named REST API 4.9. You can also configure a prefix, and you can configure if a PDF report should be generated. Exactly. And then you can select the bird template and everything is fine. Once you have configured all these fields, you can click the Generate Pipeline Script button, and then this step definition is generated. Simply copy it and paste it into your pipeline definition, and then you're ready to go. So in our case, I will discard the changes, and then I will execute this job. Due to the fact that we have not configured any trigger, and we have to click Build Now, and then the Jenkins server will search an appropriate Jenkins slave, which can run the test case. And if the slave, or if no exam is installed at the slave, Jenkins is also able to install Jenkins, as Rainer has already mentioned. No, from the beginning. If the Jenkins slave has no exam installed, the Jenkins server is able to install an exam installation on this slave. So that's the procedure Rainer has described earlier. And once the test run has finished, you can view the uploaded artifacts like the PDF report. You can also have a look at the test results. So here we can find our 4 test cases again. And if there is something, some problems within the test cases, you can also have a look at the console output. So this is very similar to the console output at exam, and you might find your problems within this log without looking to the logs of the exam client. So that's it. That was a little tour on how to enable Jenkins to run your test suites continuously. And now I will hand back the micro to Rainer, and he will tell you something about the next product, the Test Cloud Controller. Thank you for now. See you later.
So thank you, Rudy, for this nice little tour. Okay, now after we have seen the XM Jenkins plugin and how XM can interact with a build management system like Jenkins, I'm going to show you another approach and another different interpretation of having XM in a continuous testing workflow. It's about automatically scheduling test cases by means of the Test Cloud Controller. So the Test Cloud Controller is also a product by MicroNova, and it helps you to assign your test cases to the available test resources. I'm going to explain you this about the principles of the TCC. That's just the acronym of the Test Cloud Controller. The Test Cloud Controller itself is a server component which comes up with multiple features such as scheduling of test cases, balancing them, monitoring your current tests, also do a maintenance of your HiL setup and of the test resources that you have, and also has capabilities to think about an invoicement component. But to start with the explanation here of the principle and the architecture of the Test Cloud Controller, let's start on the right side here. So where you have a tester cloud to explain you the principle of what stands behind the Test Cloud Controller concept. So the tester cloud here, which is in charge for doing the implementation of the test cases and getting the test suites prepared, is just sending test orders to the Test Cloud Controller, to the server. And in this case, there is a decouplement that a tester cloud is not in charge of the execution of the test cases itself anymore inside the client, but there's a decouplement of implementation of test cases and the actual execution. So the test orders, they are picked up and stored at the test cloud controller server. It also stores the Python code that has been created, or the latest state of your Python code, while you have scheduled your test order to the Test Cloud Controller. As a next step, the Test Cloud Controller here has a HiL cloud with registered HiL resources. This can be HiL resources spread globally here, like examples that we have here. The three examples are HiLs by MicroNova, DSpace, or AITA's HiL. They are spread in Germany, China, and USA. And each of those HiL systems, they can come up with the capability to have multiple configurations, like simulation models or connected software at the test benches and so on. It's not only specific about the configuration of the HiL, but representative for the configuration of your test benches and about their capabilities. And the idea is now that the test orders that have been scheduled to the Test Cloud Controller find their way automatically to the appropriate and matching HiL configuration or to the test resource, which can actually launch your test cases you have scheduled with the Test Cloud Controller. So this means the tester, when he passed or scheduled the test order to the TCC, was providing some information about the appropriate HiL setup or the test resource where the test can be executed. So in this case, you can, thinking about the balancer and the scheduler, you can execute your entire test scope on all the available test systems, and also think about a parallelization of the test cases, because thinking of test campaigns, they can be split up to multiple test resources that are connected to the TCC. As a next step here, after the tests have been scheduled to the test resources that are registered to the TCC service, the tester again can retrieve and obtain the test results from the TCC server. Just means that the HiL cloud and the test resources are producing the results, and surely the tester will be downloading those results back from the TCC server instance. So again, the main features to give you a better explanation about what the Test Cloud Controller is capable of. So at first, the TCC is decoupling the test orders from the actual test bunch. So there is one team which is responsible for the implementation and the design of the test cases, and you have the test resources another team could prepare at the different locations spread globally. The TCC also enables you to have an automated or manual HiL configuration, so you can define all your resources and also do an adaptation and adjustment of the HiL configurations. So maintenance jobs of your HiLs you have registered to the TCC service. And you can also think about a software or hardware HiL switching, because we are able to start some scripts to switch and detect the appropriate configurations that are available on your HiL systems. Also, the automated distribution of the test orders to the appropriate test resources, as I mentioned, is one of the key features of the Test Cloud Controllers. And thinking of test campaigns and the balancer aspect of the Test Cloud Controller, you can also split them up to multiple test suites and execute your test runs in a parallel way. Invoicements are also possible based on the required test time that is recorded by the TCC of the registered test resources, and you can also create statistics about the HiL usage rate. So yeah, the statistics is definitely present where you can do an invoicement based on this. So what I have brought to you here is a conceptual model to just show you up the potential of both products. XM as a test automation solution, and yeah, the enabler for a continuous testing process, and also the access to a virtual environment by means of the test cloud controller. So both tools together go virtual. And what you can see here on the illustration is like this virtual environment here with multiple components, starting with the TCC server here that isn't installed here now on a Windows system, but runs in a Docker container, and yeah, already brings up all the required resources that it needs, that the server needs to be instantiated. And next to the Docker container of the TCC server, we also have the TCC workers. And you can just imagine the TCC workers as a Unix-based representative of the XM test runner. It just acts, or is only suits for the execution of the scheduled test runs and the test orders. And surely also the TCC worker as a Unix-based test runner is also running in a Docker container. The interesting thing here is that, yeah, as you might mostly be familiar with, having your XM client connected with a real HiL system here, now that in this conceptual approach that we have connected a Nova Cards virtual. That's a virtual real-time simulation application the TCC worker is connecting to, and you can just think of a virtual environment where you can do tests with your simulations and so on. But it's also possible to think about a mixed mode operation, like using IO devices to connect and to communicate with your real hardware components or with a real HiL, and also use the real-time Ethernet protocol to communicate between your virtual simulation and the real components. So just to summarize again up the benefits about this. So it's extremely time saving because you can parallelize this. You can have multiple instances of the TCC worker or also of the Nova Cards virtual simulation application. And the possibility to scale this is definitely clear because of the aspect that it's a virtual environment here. So the possibilities to think about any scalability of this system is definitely also something which will affect your costs and definitely reduce your costs by the lack of real components, and bringing the XM workflow by means of a continuous testing process here to the next level of automation. So enough again of me. Let's do it like before. Rudy is going to give us a demonstration about how the test cloud controller works, how you can get your test resources connected, and also show us the web application where you can do the HiL configuration and so on, and check on the tasks that have, or on the test orders that have been scheduled. So thank you, Rudy, for taking over again.
Thank you for your introduction, Rainer. So here I am again, and now we are going to have a look at the TCC. And before switching to the XM client, I will show you the web interface of the Test Cloud controller. So this web interface, I have to log in at first. So this web interface allows you to manage projects, it allows you to manage configurations, it allows you to manage users and user groups. As already mentioned by Rainer, the TCC or the agents provide a specific configuration, and the tasks can be scheduled requiring a specific configuration. And here is the page which allows you to manage these configurations. And once you have created your configurations and you have agents supporting them, you can monitor the agents with this page. So this page gives you an overview whether which agents are available, which configuration they are supporting, and some more properties of the agent. In addition, you can have a look at the statistics of each agent. So this agent hasn't done anything. And you can have a look at the utilization of the agent. So you can have a look at how many minutes an agent was active each day. In addition to monitoring agents, you can also monitor tasks. So you can have a look at this page and see whether a task has been scheduled, whether it is currently running, or whether it is already finished. If a task is not yet finished, you can change its priority in order to improve its, or to make sure that it runs earlier than some minor prioritized tasks. Once your task is finished, you can also view the statistics within the web interface. So after showing you the web interface, I will now switch to Exam. And within Exam, we will use the same test suite than before. The task of scheduling or the procedure of scheduling a test suite to the TCC is very similar to running it locally. Before we can schedule a task to TCC, we have to log in. And once we are logged in, we can double click the test suite. And now we can use this fancy button next to the old start test run button. And a dialog very similar to the dialog we saw before opens up. But this dialog offers some more configuration possibilities. So we can select a project the task should belong to. You can also configure the priority, and you configure whether the task should start at a specific date or finish before a specific time. In addition, you can configure the configuration, and you can also check whether there is an agent available which can run this configuration. So if this icon is green, then you're sure that there is an agent which can run this configuration. In addition, you can configure the report configuration, but I think this configuration is very similar to the old one. And you can upload some additional files. So with this dialog in here, you can select a directory on your file system, and this directory and its contents will be uploaded to the TCC server and then provided to the agent which will run your test suite. And then you can use the contents of this folder in your test case or you can use it to set up your test case. Okay, once you hit the finish button, the task is scheduled to the TCC server, and this view opens up. This view can be used to monitor your tasks from within Exam. So this view is very similar to the view to the web interface, or to the tasks page of the web interface. So you can also have a look at the state and whether it is already started or not. Once the execution of the task is finished, you can right-click on your task and download the report if a report is available. And if you have decided that it was no good idea to schedule this task, you can also stop the cloud test run or kill it if it has had, if it is, if the task has already started. Okay, that's it. That was a tour on how to or which possibilities you have to configure the TCC and how to schedule a task, and also how to retrieve your reports back onto your agent, back onto your Exam client. So I'm finished with my live demo now, and now it's Raina's time again. And I will thank you very much for your attention and say bye. Stay healthy.
Thank you, Rudy, also for this presentation of the Test Cloud Controller. And if you are still interested into one or even both of our products here, enhancing Exam in the means or in terms of continuous testing, then I'm going to summarize again both of our products here and also explain you the typical areas of application, both for the test cloud controller and also for the XM Jenkins plugin. So the playground normally of the XM Test Cloud Controller is one where you can think of a dynamic test distribution, where you have an environment with varying and heterogeneous test orders, that you do not have repeatings of the same test orders over and over again, but where also you have various test systems. Because since one of the key features is the management of the agents or test resources, as I called them before, this is one of the strengths that the Test Cloud Controller can deal with this variety of test systems. And also, if you're working in a team or thinking of automated tests, where a role separation between the tester that are implementing the test cases and the test infrastructure is actually possible. So the typical application of the Test Cloud Controller where you can benefit best is for those of test houses or when you have commissioned test engineering services for any products that you're getting supplied, like validation of software applications or ECUs. So on the other hand, the XM Jenkins plugin definitely makes sense if you already have your software development connected to a build management system like Jenkins, and if you have a more static and recurring repeating validation of the same tests, so that the test scope is not changing too much, but you can just think of code integrations and rerunning your tests for a validation. Also, where you can easily think of an automated build, setup, and configuration of your testing slaves. This means installation of your XM client, and this shouldn't be a problem, that the installation is not too complex using XM on the testing slaves. And also where you rely on continuous test statistics here for the development team, then I think the best choice would be to think about the usage of the XM Jenkins plugin. So as the Jenkins plugin is more or less the classic CI tool or continuous integration enhancement for XM, it is definitely the tool that could directly support the development process, and a closer relationship is to the development process here definitely given. So I hope this could give you a nice introduction into both of our products, the XM Jenkins plugin and the Test Cloud Controller. As I mentioned already at the start, the documentation when you have installed our tools is provided inside them. You can also find on the Jenkins project our open source XM Jenkins plugin. The XM REST API plugin is one of our licensed plugins, also like the Test Cloud Controller. And as always, if you need advice on the usage or how to install them, or even demo licenses to evaluate those products, you just get in touch with us. And my final words before we start with the questions here, we would definitely be happy to leverage also your testing process to a continuous testing workflow with our tools. And you can find our additional infos if you just scan the QR code. And please stay tuned with our webinar series. And also this one will be recorded and released on our YouTube channel. And keep in touch with, we're coming up with more interesting webinar sessions in the future here. So now I'm going just and wait for your questions if you have any. If not, then thank you very much for your attention.